In this demo, I'm going to show how Giraffe can be used for large-scale master planning. Now, it's much the same way in which Giraffe is used for small-scale site planning or site feasibility, plus a little more, plus a few extra tricks and techniques. But the first thing to do is understand exactly how Giraffe works at a low level. And when you do that, to blow it up to a high level will be quite straightforward. So the first thing is Giraffe is letting you overlay the data. So this is the geospatial data. We connect to tens of thousands of data sets that are in public. But if your data is not there, you can very easily connect to it to a map server or feature server or an OGC server of some types, WMSs, or upload shapefiles, other geo formats like a GeoJSON, or just raster, like just some screenshots. You can geolocate them. And say someone's done a sketch of a master plan, you can just upload that sketch and model over it. And that's very critical when you're master planning, because basically that's the context. That's what's going to drive your decision making, perhaps more than any other single factor. Now the next thing that Giraffe does is lets you draw shapes straight on the map. So let's say I'm looking at this site over here. I'm going to draw a building. You can see it's to scale, it's geolocated, and I can sort of change things around. Now, currently, when I say building, it's actually just a polygon. So to make it a building, we have to give it some data, so give it some assumptions. So I'm going to say this is a residential building, and all of a sudden that building pops up. And I can add levels or remove levels. And the color and the areas and the number of dwellings that Giraffe is suddenly displaying on this right-hand side are coming from the intrinsic properties of this polygon. So its area, its perimeter, and the assumptions in the residential usage. So Giraffe typologies or usages are the controlling assumptions which sort of underwrite the deal. So for example, if I get rid of all 3 beds and make this building a combination of 1 and 2 bedrooms and leave its efficiency untouched, I hit save, you'll see down here now we only have 1 and 2 bedroom units visible in the scheme. And that's because this building and these assumptions are combining to this output. And I'll show you in a bit how you can make custom analytics. But for now, as long as you understand that Giraffe is a data-rich map of the world upon which you draw geometries and you assign assumptions to those geometries, and that means that Giraffe is able to use those geometries to drive analytics and reporting, you've got the core of Giraffe at a micro scale or a site scale, but also at a macro scale. But when we're talking at a macro scale, often the geometries don't just represent buildings. So let's jump to a macro scale, something like 5 square Ks, 5 square kilometers. So that's even this gigantic area. That's only 4 million square meters, so 4 square kilometers. So I'm not going to master plan the full 5 square kilometers, but I'll start doing a big master plan. And the first tool that Giraffe has to help you do that is what we call land uses. So that's something like commercial core. So I could say, look, I'm going to draw a commercial core in my new master plan zone like that. And that's just a big blob. And if we open that up, it's got a floor space ratio, a height, a site coverage ratio. And that's enough to calculate, without drawing the buildings, what the built area would be, because that's going to be the control to which the private sector developers are actually going to build. So they're not going to build the blob. They're going to build lots and lots of buildings inside the blob, but those buildings are going to add up to the floor space ratio times the area of the blob times some take-up factor. So let's say we're going to do that, and something like, let's do this. We'll add supporting the commercial core. We'll have some high density mixed use, and then maybe some medium density mixed use, kind of folding down, and then down here we can have some residential. And I'm zoning now. This is sort of a strategic zoning plan. And the reason we are doing it like this is because, let's call this low density residential, is because we don't want to overwhelm ourselves with detail. If we do, and we start arguing about street placements, etc., we can very, very quickly become overwhelmed and start missing the wood for the trees. Right. And let's say now, let's actually add some roads. So what I'll do is I'll grab that, I'll use the X key and do something like this. So we're just going to connect these roads on like that. And then maybe there's going to be a cut through road, something like this. Okay, there we go. Now, what we can do is we can pull out the road reserves and actually show what they would look like. Or we can leave those road reserves visible. And both methodologies, from my perspective, work great. I've seen in various cities both of them taken. I'm actually going to cut the road reserve out just so we can see it explicitly. And I'm using liberally the X key. If I turn on the actual land zoning in New South Wales, you can see they do not cut out the road reserve. You can see the polygons touch. They don't give a gap for the road. Whereas if I turn on the cadastre, you'll see there's a gap for the road. But the land zoning itself goes over. In fact, for certain roads have their own SP2 use, which in our world is a special purpose use, which we very well could do here. So one could, if one were keen, draw something like this and give it a special purpose use, but I won't. All right, this is looking good. Maybe we do this. Now I can use the eyedropper key to lower the density over there. Let's call this medium density residential. So you can see there. Now that transition from low to medium to high is not right, but I have full control over the assumptions. So I'm going to get my medium density residential. I'm going to set that to 22 meters. And I'm going to save. That's going to jump up there now like that. And this is starting to look good. I may say, why don't we put a bit of a high residential core over there? I may actually say, this commercial core, we're going to override the height. So I'm going to grab a height property over here, and I'm just going to override this at 100 meters. And this will start to look familiar. This will actually start to look like a town plan. Now, this is only half a square kilometer. So despite how crudely I'm working, you can see how long it's going to take to do 5 square kilometers, about 10 times as long as this. So I'm going to stop here, and I'm going to quickly just add a measure just to show what we can do. So why don't we add the derived population here? So I'm going to add a measure, and I'll say projected population, and it's going to be in people. And I'm only going to apply it where the usage is equal to high density residential, medium density, low density residential, and also mixed use. So I am not going to use this actual residential key usage. That usage is a building usage. So I'm going to do that. So that's going to filter the geometry, the giraffe model. And what I'm going to do is I'm going to grab the area of the feature and I'm going to multiply it by the floor space ratio. Then I'm going to multiply those two together to get a total yield. So the site area times the floor space or floor area ratio, which gives a total area. Then you divide that by 100, assuming an average of 100 square meters per dwelling. Maybe let's assume 80 square meters per dwelling. And then we're going to multiply all of that by a projected population, like household size. So let's say it's 2.2 people per dwelling. Right, and then that's 29,788 people. I'm going to lower the precision to to 0 decimal points, and then I'm going to do a little trick here where I'm going to take this and I'm going to divide it by 100, and I'm going to cast that as an integer, and then I'm going to multiply it by 100, just so I get to the nearest 100, the number of people. And then, yeah, and then I'm going to save those changes. Okay, so the modeled out number of people here is 29,700, and that's going to be sensitive to increasing the zoned area. So as we zone more areas residential, those numbers go up. And it's also going to be sensitive to the floor space assumptions. So in this high density mixed residential, if we increase the floor space ratio and we say we're going to go to 12 and we hit save, that number is going to jump up to 52,000. All right, so that's me changing the assumptions and seeing them in the analytics at a land use level. So why don't we start actually doing some build form, and I'll show you how that works. What I'm going to do is I'm going to put this on a layer called the land use layer, land use plan. I'll create that, and then I'm going to turn it off. And this is a very nice thing about Giraffe. You can just turn stuff off. So we've still got that data, but it's on a layer. And now I'm going to show you a few extra tricks. So if you remember how I built the site plan, where I just literally drew a building manually, in this scenario when we've got sort of thousands and thousands of square buildings to draw, I'm going to actually put this down like this and just lock it so it's visible but not editable. If we were to draw every single building manually, an 800 square meter building is actually a good size for an apartment. If we were to go like this and this, it's going to start taking a very, very long time, far too long to be worth it. Giraffe does allow multiplayer, so we can share this project and then other people can hop in live. And so you can actually make pretty rapid progress just by copy pasting stuff around the map and designing bespoke sites. So say, for example, this is a land use, this is high density mixed use, right? So I could say this was my responsibility. My team has given me these sites. I could very quickly do a podium and make it retail, 2 levels, straighten it up, pull back like this, and then draw some commercial on top of it. 2 levels of that, or 2 levels of that, and then copy and paste that and get some residential on top of that. Shrink that down, right? And you can see I'm penetrating the height plane as allowed by my zoning type. So maybe I'll lower that number of levels, and I'll do more of a sort of a U-shaped building. So we're not doing a point tower now, we're sort of doing an actual U-shaped building. And at this point, you can see I'm slowing down because I'm trying to get the built form accurate. So a 20-meter depth for the buildings is actually buildable, or else you're going to get these very deep apartments. And if I turn off the land use plan, you can see what we're dealing with over there, which is a little, it's not a building quite, but it's a much more detailed envelope about what a building may look like. It's taken all of 3 seconds, and which is good because we've got a lot of site to do. So if we turn this back on, get it back down to 10, we can then start going sort of site to site. And of course, we can use liberal use of copy paste where we can, but this is still quite a manual and slow process. I'm going to change the render methods here and just turn that on. And that's for some reason turned that on. That's fine. And that just displays the floor plan. So now you can actually see more what we're looking at. And as we're working, what Giraffe's doing is it's gathering these areas and it's grouping them up and it's looking at them. What I would actually do is in my settings here, I'll turn off the charts, and I will also group by layer. So we'll see default in the land use plan. There's no projected population on the default because remember in this metric, we only apply it to those land uses, not to this residential use. So to apply it to the residential use, what we would do is duplicate that. And then hi-fi pop forecast. And rather than doing this, we will filter it down to the residential use. And we'll go area times, we won't go to floor space ratio. What we'll go is net area. So actually we'll go saleable area. And the calculation will be a little bit different. It's saleable area. There we go, divided by 80, star 2 times 2, and then we save those changes. And that's only 2,000 now because we've got a lot of sites to fill up to make this number match that number. So hopefully that makes sense. And now in the last few minutes, what I want to do is I want to show you a couple extra tricks. And now in Giraph, we have a whole set of ways where we can automate things. So say, for example, we're doing some landscaping plans and some street plans, built form, public plans. I want to do this park. Now, I want a park, I want it to look beautiful. I want lots of trees of different sizes, but I don't want to manually draw each tree. And what Giraph allows us to do is to define these logical flows. We call them a flow. And what they are is they take a geometry, which the user draws, which we call a feature, and they just do things to that geometry. So in this instance, it grabs the geometry, fills it up with points, and then makes each point a tree. And that's how you get this. Oh, it also grabs that geometry, it rounds the corners. So you see the raw geometry is pointy and the derived geometry is round. And this automation at a geometry level is extremely efficient. And I'll show you a few more of them. So here's one here. This flow, if we open it up, is a bit more complex, but all it's doing is it's it's using our subdivide lots algorithm, and then it's doing a few things. It's finding one of the edges of the parcels, and it's setting the height in relation to the distance from that edge, and then it's applying a usage. So if we go like this, it looks like this, and we have these parameters where we can make these buildings bigger or smaller. We can scale them up heaps or down heaps. And if we change the edge, we can change kind of where their heights are biggest and smallest. And I've introduced some sort of random variability to the height, which we could expose as well. And the thinking behind this is this zoning plan, probably people are not going to exactly build to this height, right? Depending on the market scenario, people will do different things. And maybe someone gets an exemption, or maybe there's some existing buildings. Maybe commercially it only makes sense to build a little bit. But the point here is that the city is going to be, this uptake is not going to be 100% uniform. And if it was, it probably could, like, it very well might be an adverse result. Like it may not look as good as what we'd want. So here's a kind of accelerated way of filling this with realistic looking built form. And as we're doing this community use over here, this is all being calculated live, and these analytics are reaching into this. And because we're separating default and the land use plan, we are getting different, we're looking at the same land use plans with different lenses at the same time. So that's one kind of acceleration. Of course, a really nice one like this is for public realm modeling. So I can draw a line, I can use my eyedropper and apply a road, and this is applying a cycle path and assigning some trees to the road. And I can very quickly add to that by drawing more road. And Giraph is pretty good at connecting this stuff, so it'll try and connect those for you. So if I make those two and that 12, draw another road here, we're starting to get something that's more visual, more representative than what we had before. And you can see I'm actually drawing this very loosely in freehand. You obviously have the option to import geometries and assign these rules to them in a much tighter way. Now I want to show you the next level up. So this is quite a simple automation. This, on the other hand, is quite a complex automation. What this automation is doing is it's taking that simple automation and it's assigning it to multiple parcels. So we're actually iteratively assigning these rule sets to these parcels in such a way that you get this really nice sort of urban effect. So we're using random numbers and iterative application. So take a site, subdivide it, and then subdivide each subdivision to make buildings and apply different rules on each subdivision to get this kind of not organic but urban appearance. And so you can see the approach I've taken here. I've actually preset these rules up. And so what I'm able to do is say, okay, well, here's our urban core. Why don't we do this? And then we go Y and eyedropper that, and we get that. And that's not exactly right. Our urban core is a bit higher. So we'll increase the height, something like that. And then we've got to adapt it to the street, something like that. So this becomes very fun. Now, this slanting, these parcels that the algorithm is generating are not quite right. So what we're able to do is do stuff like this that actually straightens them out. And you actually get these really nice semi-organic, semi-unorganic built forms that look awesome. So that could be urban core, and this could be mixed use. And what AllGiraffe's doing is assigning these rule sets and then allowing the user to tweak them in various ways, sort of kind of quickly. And almost no different to what we were doing before, just the computer's doing a lot of it. So rather than manually drawing rectangles and copy pasting them, the computer does the copy paste on our behalf, which is lovely. And much more representative, right? So the I guess the intention of doing something like this is that you get a more accurate feeling of what this place would look like. Now, it's not 100% accurate, and it is honestly a little bit susceptible to misleading you, but it is nevertheless often useful. So here you see that's grown too high, so I'll just factor it down. I'll factor its scale down. And it's convincing. And let's do one more of these. So we'll draw geometry here like this, pull it back like that, and do that. And then why don't we draw up an inner city park? There we go, kind of like Times Square style vibe. So you can see the approach here is that I'm an architect and I'm drawing and thinking, and the computer's kind of going along with me. And maybe here we have to draw another road, and maybe this road is very roady. It's not like avenue-y. It's a proper 30 meters of tarmac with a wide 4-meter sidewalk, and trucks holler up and down it all day, something like this. There we go. To get an idea just on, like, you see that's too big for me. So what we can do here is we can change this to a smaller subdivision target, something like this, but even then that's not working so well. So we can slice it. We have a lot of levers to pull to make this algorithm do what we want it to do. I think that's maybe slightly too big, so I'll go 8, something like that. Yeah, that's looking pretty cool. And where we want to, like say we've got a hotel precinct, we can actually manually design. So we can say, this is a star site, this is a key site, strategic. We're going to design something really good here. Either you or your architects can hop in here, we'll put a hotel, and we'll make it look designed, like something from Rem Koolhaas or Zaha Hadid. And let's make this retail. Okay, so there's our iconic building. Maybe let's break the grid. Something like this. Get alignment to that street. Yeah, that's cool. Won't stand up, but next week's problem. Now, when we look at this, I just want to add a few. The forecast shows 8,000 people. I think, we're a bit shy. We could be adding more people over here. So we're designing a really large urban environment here, a really large one. So I wouldn't underestimate the scale of what we're doing here. We haven't even filled this. So if you're talking about 5 kilometers square, depending on your density, you're looking at a huge populations. Let's lower that down somewhat. There we go, a bit lower. And we're talking about, in terms of areas, 500,000 square meters of commercial just in this little rectangle, although we are double counting some of this, so to bear that in mind. But we're not mucking around. All right, now what I want to do now is I want to try one more thing. So this, I want to change the edge here and then factor that down to 12. Yeah, we go, maybe 11. These scripts that you're looking at here, they can be built by anyone who is competent in Grasshopper or computational design, Dynamo, Python, etc. So in-house or we can do it as well. Okay, so we're up to here, and what I'm going to do is I'm going to pop these things on a template layer. And then turn that layer off. And then I'm going to, this default layer, I'm going to put down to 97 so there's no sun, and I'm going to turn off the levels. And that's going to help my graphics card from a performance perspective. And do I feel happy about this all? Yeah, probably. I feel like we need some more of this over here. And like that. And we also need them over here. Like this. And we'll have to do something like this to straighten it up. Yeah, cool. And maybe let's put a corner park there actually. And let's just factor these guys down a bit shorter. Something like that. Cool. All right, so we've got ourselves a pretty good scenario here, and Giraffe's doing most of the work for us. And I want to try get some renders out of this now. So let's get the open Visoid. Okay, so we're over here now. It's looking kind of good. Let's say we're ready to rumble. Let's do one last signature building in our precinct. So let's put sorry, I'm drawing on the wrong layer. And I'll use the polygon. Let's put a stadium in. A golden egg. Just give it a height and a color. Not gold, but at least bright white. Something like that. And I want that 13 to be, yeah, good. Okay. And let's also just make him in a deep green park. There we go. Something like that. The theatre precinct. All right, this is the urban plan. Now let's see if we can get some renders out of it. I'm going to turn the satellite layer on. And I am going to take a screenshot. And I'm going to open Visoid, log in, and see what we can do in real time. Whilst we're waiting for that to upload, we'll come back to here. And I'll show you another way that we can use to get some realism in these buildings. And that's actually using Giraffe's native vector renderization. Now the way that works is we are going to apply a algorithm that's going to create a facade. So just like these algorithms create a built form, we're going to use a different algorithm to create a facade over here. And I'm not going to do it from scratch. What I'm going to do is open my template facade project. And here it is. Okay, that's a beautiful little project. I want to copy this. And I'm going to go back to our plan. And I'll check on Visoid as we're there. Okay, great. Now, aerial view of modern city, summary, Australia, green, vibrant, many materials, modern. And the input level is a volumetric in the park. And let's do 4 images and generate. Okay, so we'll see what the algorithm, what the Visoid can do. And while we're waiting for that, that's our artificial intelligence friend doing our job. and we'll keep both of these. I'm just going to paste this geometry in. There it is. There it is. Okay, so you can see here I've pasted this in, and it's got a facade. So what I'm going to do is I'm going to do that and drop the number of levels and drop the stack order, and then get my design back. And now I've got a building with a design, with a facade on it, which I may be happy with. And maybe I'm going to update this building. Maybe I don't need this silly block and stack. We're going to do something like this. But this thing certainly does need a change. It needs more facade on this road. So if we go to this and we go to the edge selector and we choose this, we're going to select that. And then on the blank facade, we'll unselect the same. All right. And then on the facade 2, the offset, we're going to parameterize this stroke dash. So instead of, sorry, on lever 2, instead of a small stroke, we'll get a big stroke, like 3. There we go. And this is a way, one technique among many, of doing detailed rendered or visualizations on buildings. So that's giving a much more, I don't know, scaled, picturesque version of what this building may or may not look like. We go back to Visoid, and there we have it. So it's picked up that that's a stadium. Here's our built form, a commercial core in the jungle. There's the existing built form. And if we do this, and this, that's real. I mean, this is really cool. We've got to here very, very, very quickly. And again, I want to emphasize that these can be mixed and matched. So you could put this in a Photoshop and overlay this and that. I kind of like this one because it's got a bit of variability in these buildings. These are a bit different to those, to that, so sort of neighborhoods. All of the areas in the giraffe area schedule over here, and the modeled out population numbers, etc., are coming from what you see on the screen. They're tightly coupled. There's no like, oh, we forgot to copy paste it into Excel correctly. We're looking at the old version or whatever. This is what it is, which is very helpful. And hopefully as well, you can see where I've left stuff indicative and by the algorithm, and where I've dived in and gotten very fine-grained on the control of what the buildings look like and how you can do that strategically to use your effort efficiently. And also how, because we're calculating things in 2 ways, as in we're using the land use plan and this indicative build form plan, we have much more confidence that our numbers are for real. So when we're presenting up into our hierarchy, investment committee, stakeholders, we can rest easy that these things kind of match. So hopefully that's given you quite a lot of idea about how you can use Giraffe to do land use planning at scale. And like I say, this is probably a 20-30 minute walkthrough, and we've done about half a kilometer. So if you multiply it by 10, 200, 300 minutes, so sort of 6 hours to do a 5K master plan. Not too bad.